Hello, my name is Osmeid Alvarez Almaguer, and this is the project video presentation for Science 2. The name of my project is Electromagnetic Levitation, Maglev, and Hyperloop. So a quick overview would be electromagnetic levitation is a method in which objects are suspended by magnetic fields. Gauss's law for magnetism tells us that the divergence of the magnetic flux density field is zero. More precisely, the total magnetic flux through a Gaussian surface is zero. This is represented by vector field lines going from the north pole of the magnet to the south pole, so that then when they come into contact, they generate a force opposing each other, if they are north to north pole or south to south pole. So when the same pole of two magnets come close together, a repulsive force is experienced, because the lines of force repel each other. This does in fact cause momentary levitation, but because the system is so unstable, the magnets they tend to tilt away from each other, trying to get a hold of the opposing pole. So I provided here some of the Maxwell equations, and the slide is called Electromagnetic Levitation, so I make a quick overview of it. So to make the system stable enough, the use of electromagnets is necessary. An electromagnet is an inductor with a soft iron core. By passing current through the wire wrapped around the core, we generate a Lorentz force that repels the other magnet. According to the equation, magnetic force is equal to the current times the length cross product with the magnetic flux density. This happens because by passing current through a solenoid, we generate a magnetic field, as explained by Ampere's law, which states that a changing magnetic field will produce a rotating magnetic field. So basically, we can control the electromagnets by turning off, on and off the current. Using Hall effect sensors and electronic components, we can manage to turn on and off the electromagnets. So that kind of gives a balance to the system. This causes the electromagnets to repel or attract the magnet as necessary to achieve and maintain stability. And this slide is on Maglev. So the magnetics used in the Maglev trains are superconductors, which allows for stronger magnetic fields to be generated. When these magnetic fields interact with the conduction loops inside the guideway, an electric current is generated, which in return generates an opposing magnetic field. This happens according to Lenz's law, which states that the direction of the current induced by a changing magnetic field is such that created magnetic field opposes changes in the initial magnetic field. So basically that makes the train levitate. And then the future of electromagnetic levitation would be Hyperloop. It was, I think, initially a project thought of by Elon Musk. The system works by electromagnetic levitation, just like maglev trains. The magnetic levitation and propulsion would be done inside of a vacuum tube to prevent the loss of speed due to drag caused by air. And this project would also be, in terms of power, it would be efficient. And new systems are being developed using the concepts of magnetic fields and Gauss's law for magnetism. These are some references. I got some of it out of Wikipedia, alpha.com, and www.energy.gov. Okay, thanks. That's it.